This topic is called average value, but I really feel like it should be called average Y value, and I'll explain why in a second. So you can see here that we have Y equals X graphed. Okay, Y equals X is graphed, and the question is, what is the average value of Y over the interval from 1 to 5? So we're talking about specifically from 1 to 5. Now, what do you mean by the average Y value? Well, there's a bunch of coordinates on that red line that I just drew. There's this coordinate, there's this coordinate, there's this coordinate, there's one really close to it, right? And I could write the coordinates for all of those out. So for example, this one might be 1.7 comma 1.7. This one here might be a 3.2 comma 3.2. And the question is, what would the average be for all those green points for the Y coordinate? Well, how many points are on this line? Well, technically an infinite number, right? I can keep drawing a point that's in between. So for these points, if I were to write the coordinates out for all of them, what would the average Y value be? Well, you might take a guess here that it would average out to 3, an average Y value of 3, because that's right in the middle of the line. And you'd be correct. This is a really easy function to do, though, because it's completely straight. What if instead, though, you had a bunch of negatives here, and it was like this? No, it's much more confusing when you're dealing with a curve to try to figure out what that average Y value is. So what is the area under the curve from 1 to 5? And so please notice that this is the exact same function, right? Y equals X was our function. So here's my Y equals X. And we were also talking about from 1 to 5. And so I'm just going to calculate this, and we're going to determine how does this relate back to the answer that we got, which was 3. Remember here we got the answer was 3. All right, so let's calculate this. Our integral is going to be x squared divided by 2, and we're evaluating that from 5 to 1. Remember, we have to plug in into the numerator right here. That gives me 5 squared over 2, and then I'm going to have minus 1 squared over 2. So that's going to give me 25 over 2 minus 1 over 2 gives me 12, right? Because that's going to give me 24 over 2, which is 12. So the question is, I got 12, but I know the answer is 3. How could I get from 12 to 3? Well, obviously you would say take that 12 and divide it by 4, and that's going to give you your correct answer of 3. And you might say, where does that 4 come from? Well, you could get a 4 by subtracting these two values right here. So this was just kind of an exploration page, and it will help us understand why our formula is what it is. So here's the formula. In order to calculate the average value, we calculate the integral of that function. And then notice that we have our lower bounds. We have our lower bound right here and our upper bound here. And then in front, we have a fraction of 1 over b minus a. So let's go back to this, and you can see that we literally have the integral from your 1 to 5, because that's what this problem said, from 1 to 5, of your f of x, because remember, that's what our function was. And then I said, hey, we have to divide by 4. That's the same thing as multiplying by 1/4. Well, that's also, how did I get the 4? It would be 5 minus 1. So kind of conceptual conversation we've had so far, but moving forward, all we need to know is this formula. I kind of showed you how we got there. So find the function's average value over the interval 0 to 2. So we would have the integral from 0 to 2 of my function. And then out in front, I'd have a fraction, and it would be 2 minus 0 here. So this is my 1 over b minus a, the integral from a to b of f of x dx. See how that matches the formula perfectly? All right, let's go ahead and calculate this. So I'm going to have a 1/2 out in front, and then I have the integral of 3x squared is a 3x cubed over 3, or just x cubed, and then plus x. Remember, I've got to evaluate that from 0 to 2, and I'm going to have this whole thing multiplied by 1/2. All right, so what does that look like? Well, that is going to be plugging in 2 first, so that's going to give me, keep my 1/2 on the outside, 2 cubed is going to give me 8 plus 2, and then I'm going to have a subtraction of a 0. So it's going to give me 1/2 of 10, which is 5. And you could actually think about what this means. Remember, we have the graph 3x squared plus 1. And so that graph looks like up 1, a kind of steep parabola. However, we're only talking about it from 0 to 2. So we're talking about from the point right here, which is the coordinate, if we plug into the original 0, 1, so y value of 1, all the way up to this point right here. If we plug in 2 into the original, I get 13. So we're saying, what's the average value in between 1 and 13 on this curve? Well, we just found that the answer is 5, somewhere like right there. You don't need to do this picture every time, but I just want to make sure everyone understands what they're finding. All right, let's go ahead and let's find another one. Let's go ahead and do the average value of y equals x cubed on, we'll go 0 to 4. So just quickly thinking about what this graph looks like, we know that the x cubed function goes like this and then like that. And so we're trying to figure out from 0 to 4, and so we don't care about that section. From here to 4, and plugging in a 4, I get 64. So this is the coordinate 4, 64. And this is the coordinate 0, 0. Given all these random green coordinates that I'm drawing right here, what's the average y value? Is it closer to 64 or is it closer to 0? So to calculate this, we use our formula. We're going to do 1 over b minus a, which in this case is 4 minus 0. The integral from 0 to 4 of x cubed dx. Well, that's going to give us a 1/4 out in front, and then the integral of this is an x to the 4th over 4. Okay, and then I have to evaluate that from 0 to 4. And so now I'm going to have a 1/4. Plugging in 4, I get 4 to the 4th power is a big number, 256. Divided by 4, and then minus obviously 0, because we plug in 0 here and we're going to get a 0. Well, 256 divided by 4 is 64, so this becomes 1/4 of 64, and that gives me 16. So it kind of makes sense that it's a little bit closer, your average value is closer to here, and the reason why is if you think about the x cubed graph, it kind of is flatter here. There's more points happening there. That makes sense. All right, that's it for this lesson. Thanks for watching.